on behalf of the Global Open Data for Agriculture and Nutrition. It is my great pleasure to welcome all of you to this webinar. This particular webinar is very interesting to a lot of colleagues in the GODAN, especially the capacity development working group, because it is going to talk about soil moisture and soil mapping and those aspects. In fact, GODAN has a capacity development working group on soil, so there is a lot of synergies that we can can learn from our presenters, Dr. Adriano Camps and Dr. Mercedes Vall-llossera from Barcelona, and we are very grateful for having them for our webinar today. Both of them are academics, and they are both part of the IEEE Geoscience and Remote Sensing Society, so which is a very active group, and the GRSS, in collaboration with African researchers at the European Space Agency, working in the Barcelona Expert Center, they have been working on GEOS, the Global Earth Observation System of Systems, and Soil Moisture and Agriculture Outreach. So this project is very, very interesting to our GODAN Capacity Development Working Group. So for those of you who are new to GODAN, I want to briefly give some background about GODAN. We are an international global initiative, and we build upon high-level support among governments, stakeholders, policymakers, international organizations, and business. So the network is free to join. We welcome everyone who have interest in open data and agriculture to please join this network and contribute your ideas. And in fact, it's a kind of a network of networks which promotes collaboration to harness this growing volume of data generated by new technologies to solve long-standing problems in agriculture and nutrition, and to benefit farmers and the health of consumers. So that is the bigger aim of GODAN. And we very much value diversity and strong. We have very diverse background, people from very diverse background who are all involved in our capacity development working group and GODAN in general. So you welcome everyone from all parts of the globe to please join us and be part of this global family. And specifically, I would like to welcome everyone today to join this capacity development working group, which is because we are working a lot in capacity development activities, and these webinars like these are a great opportunity for us to reach out to colleagues globally and link ideas. So it's free to join. Just go to this URL and fill in your details, and you will be part of the capacity development working group. And we will make sure we share all these ideas in the capacity development working group and share good practices. So it's important all interested join this working group as well. So I would like to hand over now to our colleagues in Barcelona, Dr. Adriano Camps and Dr. Mercedes, and who are going to talk about their interesting project on the GRSS soil moisture mapping. So we look forward to hear from them. And after their presentation, there is opportunity for you to ask questions to the presenters, and we will answer the questions from the presenters. So you feel free to put those questions in the chat window. So I will now hand over to Adriano and Mercedes. Thank you very much.
So first of all, let me introduce you my colleague, Mercedes Vall-llossera, okay, who has been leading this project, this AfriGEOSS project. So this project has been sponsored by the IEEE Geoscience and Remote Sensing Society, okay, in support to our African activities. I have to say that GRSS sponsors a number of activities, educational activities, and in particular, we have something that we call caravans. Okay, we carry out caravans in India, in South America, and in Africa as well. Okay, with the purpose of training and educating people in remote sensing techniques. And this one in particular was focused in soil moisture and how soil moisture can be used to make a better use of the available resources to obtain better crops, okay, and also to make, and even though it's in a more embryonic stage, to make a better prediction of some diseases that also may impact the agricultural production. So, as I said, this is one of the GRSS African initiatives to support local training, okay, for the people that are living there to use soil moisture data data that is available nowadays from a number of different satellite missions. So until present, most of the in situ data, or the data related to soil moisture, was obtained using in situ sensors, which are these probes that you can see on the left-hand side. Basically, that when you put them on the terrain, the conductivity changes, okay? And then from that, you can infer what the soil moisture value is. But of course, this is a point measurement. It does not provide the synoptic view of what is happening, and we can only get it when we get data from space. And even though the technology is known, or the principles of this technique are known from the 70s, the fact that we need to use L-band, so a frequency that is more or less around the bands that we use for mobile communications, for cell phones, okay, 1.4 gigahertz in particular, is so low, okay, that to obtain a decent pixel size from space, it has required very, very large antennas. So the first spaceborne mission that has measured soil moisture from space has been the ESA SMOS mission that you see in this plot. Okay, it's a Y-shaped array that implements a technique that was formerly used in radio astronomy, but now looking down to the Earth. Okay, even though it looks small, each of these three arms, I don't know if you can see my pointer, is 4.5 meters long, which is an incredible large structure in space. This mission was designed for 3 years. It was launched in November the 2nd, 2009, and it's still alive. Then in 2011, NASA launched the AfriGEOSS mission, okay, which lasts until 2015. AfriGEOSS was meant to measure sea salinity, okay, but it uses exactly the same band as for soil moisture. So over land, even though the spatial resolution is worse than SMOS, it's about 100 kilometers, it was also able to provide soil moisture data. And nowadays, we also have the NASA SMAP mission, which was launched in 2015, January. By June, the radar failed, but the radiometer is still alive. So it's providing coarse-resolution soil moisture maps. In the future, we may have other missions like SAOCOM, WCOM, NISAR, etc., based on synthetic aperture radars that may providing not soil moisture value in terms of cubic meters divided by cubic meters, but soil moisture indices. So the motivation, again, for AfriGEOSS is to support local training on the use of soil moisture data sets by African organizations. The main goal is to help to make a sustainable agriculture, okay, more resilient to climate change, floods, droughts, and wildfires. And we selected 2 pilot sites for the fine scale soil moisture mapping, one in South Africa, the other in Ghana. And I say fine scale soil moisture mapping because the nominal resolution of SMOS is a pixel size of about 50 kilometers, even though it is then resampled at 25 kilometers. Okay, but this is too coarse for many applications. So we have developed here at UPC, in collaboration with the Institute of Marine Sciences from the Spanish National Research Council, a technique to downscale the coarse resolution soil moisture maps into smaller pixels, about 1 kilometer size. And actually, we have made also some tests to make them even smaller, down to 300 meters. Okay, but we are missing still some data to ingest in an operational way, but we are working on that direction. So what we did in this project was to process all the SMOS data that was available since 2010 until June 2017 in the African continent. And then we invite African researchers, okay, to know about these data sets and to show them what they can do with them. This is the list of participants. On one side, we have Tony Milne and Melba Crawford, which are the GRSS connections or representatives to GEO. Myself, currently, I have a position in the GRSS Administrative Committee. Okay, and I'm also at UPC, so I'm making the liaison. I'm the link between the GEO representation and the rest of the teams, which are the ones that are marked in orange. And then and of course, I have Mercè Vall-llossera with me, who was leading the project here at UPC. And then in green, we have the people that were contacted and answered in a positive way that they were interested in these data sets. So these are the two test sites that were selected, one in Ghana, over here, and the other in South Africa. The one in South Africa was in Stellenbosch. It was to assess the use that was made of the water resources, because it was mostly based in irrigated agriculture. In Ghana, on the other hand, we had rain-fed agriculture, and we wanted also to see its application to drought and flood as a proxy for early warning of these two events, and also for bushfires. So now what you see on the right-hand side is an animation, a series of snapshots of SMOS. So basically what you see are in clear days, you see kind of a strip that goes from south east to northwest. These are the ascending passes of the SMOS satellite. Okay, you also see some holes in the image. This corresponds to the presence of clouds. So we cannot apply the downscaling algorithm in the presence of clouds. Okay, we are working on that when we use data, auxiliary data coming from models, etc. But this is one of the limitations that we have so far, and I mean it's difficult to bypass this problem. But in any case, what you can see is that when you integrate all these data, at the end of the day, you can make a whole time series of what has been happening. So, as an example, for example, we did an analysis of all the soil moisture in Africa, okay, from 2010 to 2015. Okay, we had an La Niña event, okay, and then in 2015, an El Niño event was developed. On the plot on the left-hand side, what you see is that when there is a La Niña event, okay, there is a region that gets wetter and cooler, while other gets warmer and drier. And during the El Niño event, these two effects, again, I don't know if you can see my pointer, but you see that the color has changed. What was wetter and cooler becomes dry and warmer, and what was dry and warmer becomes wet and cooler. So these are basically the synoptic view of what is happening. And here you can see and correlate that with real data, satellite data coming from SMOS. So you see the difference between 2015, okay, when El Niño was already present, and 2013 in the middle of La Niña event. So you see that this region has become significantly drier, and this other one is also wetter, but there are other regions that have become wetter or drier. And here you have the scale from minus 0.1 to plus 0.1. This is significant. This is in cubic meters divided by cubic meters. So all this data is free, and it is accessible through the BEC website. BEC stands for the Barcelona Expert Center for satellite data processing. Okay, here is the web address. We receive SMOS data in near real time, less than 2 hours from acquisition, and some products are produced. In particular, since we are now talking about soil moisture, global soil moisture maps at the nominal resolution, remap at 25 kilometers, okay, and at 1 kilometer resolution by applying this downscaling algorithm, combining SMOS and MODIS data over 3 pilot test sites. One, which is the Iberian Peninsula, the other one that is Ghana, and the third one that is South Africa. Again, all this data is available, so you can go click. The only thing you have to do is to register, but this is free. Okay, this is just to have a little bit of control, because our sponsors want to see that this project is useful. All this infrastructure has been supported by the Spanish Ministry of Science and Education, so we need to show that there is a use of this data. Okay. Again, an example of the high-resolution soil moisture maps that we can derive. As you can see, for example, this corner over here, which is Catalonia, we are over here, has no data. For one reason is that the satellite pass was not covering entirely the Iberian Peninsula. There is another gap in Madrid. Okay, this is the capital, but this is because of the presence of radio frequency interference that affects the measurements. Okay, and there are also some points, okay, that because of the clouds or because these are the mountain regions in the top, sometimes the soil moisture retrievals do not perform well. Okay, again, the data is freely available in the website. Again, this is the example for South Africa. Some regions look like more homogeneous, so you don't really see detail. But if you zoom in, you can start seeing much better the details of the coarse-resolution products and the 1 kilometer ones. Another example in Ghana. Here you see a lot more detail. Okay, and just a side product of these soil moisture maps for the Iberian Peninsula. We have made an analysis trying to correlate the soil moisture and the, well, this is surface temperature, okay, only. So we know that the fire indices usually use other variables, wind, etc. But here we have restricted ourselves only to soil moisture and surface temperature. Okay, but not just instantaneous value, but also using a little bit the history of the previous days and weeks. To do that, we make some clustering of the pixels. We correlate it with the regions where forest fires were detected, depending on the area that was burned. And we made 5 categories. With these 5 categories, we produced forest fire risk maps, okay, that are also available in this website. And this information in the region of Catalonia is delivered every year, I think since 2013 or 14, okay? So every summer from June to September, this information is delivered to the authorities that are in charge of the coordination of the firemen, okay, so they can make a better use of the resources. Again, there are many more variables. Actually, most of the forest fires are triggered by the presence of human activity, okay? But we found a pretty good correlation between just using these 2 variables, soil moisture and surface temperature. And other byproducts that we have been able to study thanks to this soil moisture data at high resolution is the decline of forests in the Catalonia region because of the serious, severe, and persistent droughts. Okay, so after some time, when the soil moisture is below a given threshold, then the probability that this particular species basically passes away is much higher. Okay, what we have discovered is that, I mean, it's obvious a posteriori, okay, is that the species that are more let's say, from the Mediterranean climate are the ones that resist better droughts than those species that have been entering from Northern European countries, okay, and are living in our forests for less period of time. We can also monitor floods, okay, before and after the rain events. We can see the extension. And this is also important because once we have intense rains, and the soil is wetter, it means that if it keeps raining, it will be able to absorb less water from the rain. So the probability of having floods is higher. And one of the last activities that we have been involved is trying to study the correlation, okay, between the development of the desert locust, okay, and the soil moisture. So our colleagues from the University of Valladolid, which is a city in the center of Spain, have been using the soil moisture maps provided by us and trying to correlate the presence of the desert locust in Mauritania. Okay, and we are now trying to extend this study to other plagues such as the dengue in Brazil, etc. Okay, and now I leave the word to my colleague, Merce Vall-llossera.
These projects, AfriGEOSS and other projects by ESA, we try to use for engagement in soil moisture research and another application, as you can see with all this work. And another thing, we are going to strengthen the collaboration with African researchers. We try to do local training, to organize summer schools, workshops, etc. And in another hand, we are going to try to develop other added value products for local African needs. One of these collaboration was done in AfriGEOSS Symposium in 2017 in June. In Suni, this workshop was held in Sunyani, Ghana. In June 2017, around 170 participants, and this symposium try to solve some of the problems in Africa, the water, the necessity of the water, the food security and sustainability agriculture, land cover, and other kinds of problems such as climate problems and wildfires. Our work was presented here in the food security and sustainability agriculture, and we were presenting all these words, all this application, and how you can use the data we are providing in BEC. In this Barcelona Expert Center, and some people were very interested in using them. Last remarks, this algorithm you are using until now have been improved these last months, and we are obtaining soil moisture maps at continental scale. Until now, we only could obtain soil moisture maps in in local areas. For example, peninsula sizes like Iberian Peninsula, South Africa, but not such big space like a continent. Nowadays, we can obtain soil moisture maps for Europe, for example. We have been validating these results in Europe, and also we have done the same study at Australia. And we think that it will be possible to map the whole Africa continent in high resolution as a new product. Other variables we are providing in BEC are related to soil moisture, ice moisture, ocean salinity. In the oceans, SMOS stands for soil moisture, but also for ocean salinity. This satellite is providing regularly information about the salinity, and then it is very important to know the salinity in different areas. For example, the close seas, as the Mediterranean Sea, and other places. And it seems that it is very interesting for fisheries in order to know how the fishes are, and if you can obtain them. Thank you for your attention, and if you need to contact us, these are the emails for contacting.
So thank you very much, and we are ready if you have any questions to answer you.
Thank you very much, Adriano and Mercedes. Very interesting presentation. A lot of, I think, we will now open for questions, and what we want to do is to give opportunity to the participants now to ask their questions. So one question, I will ask participants, if you have questions, please put it in the chat window so we can read the questions as well. So Daniel Chinagozi is asking any plans for Africa. So you have given some examples in South Africa and Ghana. So do you have any plans for other countries like Nigeria?
I mean,
if people.
I mean, the question here is if there is a need, okay, it can be done. Okay, there is nothing that is impossible, but trying to do regions where there is not really an interest, okay, no one is going to use this data, okay, that takes a while. It takes basically somebody to do part of the processing, even though we have automatized it to a large extent, but still there is someone that has to be running the machine. And it's also occupying lots of space in the hard drives, okay? If there is no need, then there is no point to process this data at high resolution. But if there is a need, okay, because there is a food issue and you need to improve the production for crops, etc., then of course it can be done, and we will be very happy to do it.
Thanks very much. So, so the answer is, if anybody is interested in a particular area, for example, Daniel from Nigeria, they can email you, and both of you, and then, then they can, you can take it from there. Is that correct?
I mean, we will have to tune, because nowadays the server, okay, is processing automatically only. I mean, the infrastructure that is behind was set up, okay, to process automatically the Iberian Peninsula, Ghana, and South Africa.
I see.
We will need to do some extra work, okay, to make it happen for other regions, but this is feasible.
Yes.
Thank you very much, Adriano. So another question from Joanna. Thank you very much for the presentation. I'm wondering if you are linking the moisture maps with land cover types of crops.
Until now, no, but it's possible to do some relation. But until now, we are doing only, we are obtaining only some moisture map directly, but we can correlate this information. But it's also something that we have done.
Let me add something. I don't know if this is what I'm going to tell you is what you had in mind. Of course, when you retrieve the soil moisture value, you need to know basically if you have vegetation or if you don't have, and if you do, how much, okay, in terms of what we call the vegetation optical depth, which is a measure of the attenuation of the electromagnetic wave at L1 when it passes through the vegetation layer. In principle, because SMOS has the capability to look to the same pixel under different incidence angles, okay, there is no need to add this a priori information on the vegetation type or how many kilos of water per square meter of land in the surface or things like that, okay? That can be inferred somehow by the soil moisture retrieval algorithm itself, okay? It doesn't mean that in the end this product is provided. It's a subproduct that is somewhere, but is not provided as it. It may be of interest, yes, but I was wondering if you wanted to make a study and correlate to it the type of crops to see if in some conditions the production is more or less. I don't know what you were thinking when you put the question, but you need. And another thing that we are doing actually right now is in regions where there is big forest, okay, so there is a lot of biomass, to estimate the amount of carbon, okay, that is stored by the vegetation, because this also is important for climate issues, okay, how much carbon can be sequestered by the vegetation. Of course, if you go to the forest, soil moisture is not, let's say, the main driver, because you are not going to harvest anything, okay? But it's the amount of carbon that is stored is the driver there.
Yeah. On the other hand, we are working also in try to obtain using the VOD information a little bit, which is ¿cómo se llama? La recolección de...
Yeah. The correlation between the VOD and the agricultural production.
Yes, this
Okay.
is possible. We are working in this, but we need a little bit information about the production, the different crops in different areas.
Actually, this study is now, I think it's finished. We submitted recently, and it was conducted in the US.
Yes,
okay,
we
because
have been doing some studies in the Corn Belt in United States.
I see.
But
Thank
we
you
can
very
do in other places.
Great. Thank you very much, Adriano and Mercedes. So another question from Francesca, who is asking, are you using soil moisture in situ measurements to cross-validate the soil moisture satellite data? So any in situ measurements to cross-check?
We have done the validation in different places. In Spain, there is a network, Remedus network, in the center of Spain, more or less center, this, Zamora, more or less, Salamanca, and another place is in Australia, in the Yanco area. There are some networks installed every day.
it's a permanent network.
Yes, a permanent network, and you can use the data they are providing. And we are correlating this information. And now also in Brazil, we did some cross validation also in order to have different places, different areas. And correlation is nice.
And we also perform a study in the region from Indiana.
Yes.
Okay, which is a different type of climate, a different type of crops, etc.
I see.
So, I mean, but in Africa, we don't have any site, okay, where to validate the products. But these products have been, and the procedure, the end-to-end procedure has been validated in North America, in Brazil, Spain, and Australia.
Australia, okay, good. Okay, thank you very much. And another question from, I think it's a more technical question from Ivo Mehkum, who is asking, what is the file format of this data to integrate with other models of hydrology and floods, for example, SWAT and HEC MEC?
NetCDF.
NetCDF, okay.
Yes.
All right, you're making it out. Another question from Francesca, who is asking, at which stage is this dense soil moisture in Brazil?
Pardon me?
At which stage is the dense soil moisture map in Brazil?
Which depth?
Which stage?
Stage.
Yeah, stage.
I mean, we are working. I mean, it's not yet operational, okay, and we are working on it. We have a postdoc from Brazil, okay. And we are working, but we don't have anything operational yet. But we have a couple of papers and conference presentations showing the results. But it's not operational. It's not in the web servers.
I see. Yeah, thanks for the information. And Sophie Hebden is asking, how do your maps, the maps you have just shown, how does it compare to the European Space Agency CCI soil moisture maps?
We did some work in comparison with Vienna information.
Sí, son los que producen. Yes. Yeah, they are the ones that are producing these maps.
No, we did some work, and the result was the comparison, the validation was
satisfactory.
Yes.
Yes. But I mean, what they are producing is an index. Mm-hmm. So it's a bit different than a value of cubic meters of water divided by cubic meters of soil. Okay, so I mean, in general, the agreement is good, mm-hmm. But you have the density and the porosity and other variables in between to make a proper intercomparison.
Right. Okay. Thanks. The next question is from Wycliffe, who is asking, what is required for attending the next workshop in Ghana?
What is required to attend the next workshop in Ghana?
So
I don't think there is any requirement to do that. I think it's open.
okay.
What we don't know is when it's going to be, because so far we have not received any invitation or make any action from our side to go there.
Right. Okay. So will there be like a call for participants? Is it like that? So, for example, when the call comes, it will be really helpful. For example, the question that Wycliffe asked, if you could share the call in, for example, the GODAN capacity mailing list, so then they all know,
yes,
there is an opportunity for them to apply and things like that.
Yes. Okay, I'm taking notes so we can. Yeah,
that'd be great. Hope that answered your question, Wycliffe. And okay, so next question from Francesca again is there any project high resolution data for Southeast Asia? So the examples you're showing but is there anything for Southeast Asia as well?
Not that I know, not that I am aware.
Right.
Actually, this is the first request for Southeast Asia.
So maybe Francesca, after the webinar, you can you have the email of both Adriano and Mercedes, so you can contact them directly. If there's any specific thing you want asked on.
Okay.
Yes.
So there is another question from Douglas Noyoli. It's great. It's a lot of good questions coming in, and I think it's really good to have this participatory way to, get the participants ask questions and build collaboration. So Douglas Noyoli is asking, what are the best products you have ever produced in terms of spatial resolutions, and what satellite products did you use? I am asking this because at local scale, we need higher resolution products to advise farmers.
Now, we are providing at this moment 1 kilometer resolution, but we have been done the first steps for providing in 300 meters resolution.
Oh, I see.
And it's we have been doing some validation in the center of Spain, and the results were very good. It was we were obtaining the same similar results than using 1 kilometer resolution, and it is possible to obtain this resolution now.
I see. Thank you. There's another question from Mudasa Umar, who asks, how much SMOS soil moisture product is accurate in irrigated region than rain-fed region? So from your experience, what do you think, the accuracy varies with irrigated regions and rain-fed regions?
Yes. I mean, based on our experience, it's more accurate in rain-fed regions, okay, than in irrigated regions. But having said this, okay, I have also to say that it's more difficult to make the comparison in irrigated regions because we are comparing a native pixel resolution that is 50 kilometers, okay, and usually the size of the fields that are irrigated is not that large, okay. So you may have your in situ probe in a region that is being irrigated, but the parcel may be much smaller, okay, and then you are comparing with the soil moisture value that is provided at a native SMOS resolution, which is much coarse, okay. So actually we are comparing different things. But and this is something that at the beginning may look like surprising, but when you think it's not as surprising, when you downscale, the correlation not only does not decreases, but it even increases a little bit, because you are comparing a smaller pixel that is more homogeneous and looks like more, okay, and is more representative to the point measurement that you are using for your validation.
Right.
So that's, but in general, the agreement is better in rain-fed regions than in regions that are irrigated.
Thank you. And there's another question from Ivo Mek, because I think Ivo Mek asked another question, but it was not very clear. So he did ask, what is the file format of this data to integrate in other models for hydrology and floods, for example, SWAT and HECMesh? And he has asked a following question. Excuse me if you didn't get my question right. I am asking whether this product is comparable with some models in use, especially in hydrology, for example, soil and water assessment tool. So is this model comparable with this tool that Ivo Mek is mentioning? Are you aware of it, the soil and water assessment tool?
I have, if I can answer, I mean, we are providing the surface soil moisture, okay? We are working also in the root soil moisture zone, okay? We provide that in NetCDF format, but we are telecommunications engineers. We work in the instrument side and we don't work in the hydrology side. So I have to tell you frankly that we are not fully aware of all these hydrological models that you are mentioning. However, the postdoc that we have from Brazil, she is the one, she may be able to answer this question more properly than us. She's the one that knows about the models, and she's in order to derive the soil moisture at the root zone. She's the one that is integrating that into some hydrological models, but this is a bit far away from our region of knowledge.
Yeah, thank you very much. And I will suggest to Ivo Mek to please send an email to Adriano and Mercedes with your question, but they will be able to direct you to the expert who is the postdoc who is working on this, and then that way you'll be able to get exact answer to what are the kind of formats and things like that. So please, Ivo Mek, email later, and then you'll get the correct answer and the correct contact for this question. So the next question is from Nesta, who is asking capacity to detect seasonal change on how many months basis. So the question is on, is there a capacity to detect seasonal change using your product?
Seasonal
change. Seasons, change of seasons.
Seasons.
Yeah, seasonal change. So how many months basis? It's like 4 months, 3 months. Are you able to detect any seasonal changes?
We could have inserted one of the slides, because you see the seasonal variability very well in the soil moisture patterns. You see basically the 4 seasons, and actually for most of the studies, you need to do it at season level. Let me show you one thing. For example, here, this is comparing 3 months. So it's not the average of the whole year, but you take a block of 3 months, okay? Because you see the seasonal variability. Okay, in a year you see all the changes in the soil moisture pattern, and it's better to compare the same period of time in one year with the other one in order to see also interannual trends. But within the year, you can see it in a monthly basis. You can see how it changes. I don't know if no, we don't have any presentation. If you contact, we can provide you some papers and some slides showing all the variability during the year.
Thank you very much, Adriano. A follow-up question is, is it Nesta wish to understand if there are data history that may help to understand drought or some localized region of Africa? Like, is there any data history? So, for example, this one is showed between 2013 and 15, right?
Yes.
Yep. So
you have to think also that SMOS was launched in 2009, end of 2009, and it was commissioned 6 months later.
More or less at 2010, we started to have providing the good information. Yes, soil moisture validated.
Yeah, so I mean, from satellite, this is the earliest satellite data that exists.
In L-band, you can obtain, but in other satellites, but it's not the best.
Yeah, I mean, there is previous data, but again, it's not soil moisture in cubic meters divided by cubic meters. It's a soil moisture index. Okay, so from 0 to 1, and then you have to make the link with the true soil moisture.
Thank you very much. Another question from Tambalan. Yes, the first question is, how better the global data like SMOS is used for soil moisture estimation at regional scale? Any downscaling approach or suitable method for comparing with SAR?
I think I don't understand exactly the question, but for local or regional application, we are using SMOS data, but we are doing synergies with other data. Surface temperature and information about the vegetation index in order to downscale the information and obtain high resolution maps, 1 kilometer or 300 meters resolution. This is what. But in a global scale, at this moment, we are providing a soil moisture map at 25, 30 kilometers resolution. Yes.
I see. In fact, the question from Tamban, he's specifically interested in southern arid region in India. So, so is there any data you are aware of for India?
Again, this is the first question or the first comment suggestion to get data in India. Okay, but using SMOS. But I am from another side. I know that my colleagues in the US working in synthetic aperture radar. I know that there is an interest in India to try to get soil moisture, but not using SMOS, to my surprise, but using synthetic aperture radar.
We can do India as well, but at this moment the problem is if you are providing 1 kilometer resolution for the world of it's very consuming the resources, and then we are at this moment we are providing only the places that some people have
requested.
Yes.
Thank you for that answer, and I will request Tambalan to again, email directly later after the webinar, Adriano and Mercedes, and you can discuss ideas. So the next question is from Abel Chamura, who is asking: you said that the downscale soil moisture data is available for South Africa and Ghana. So can we get on-demand data for other areas such as Zimbabwe, so that we can start to interact with the product? If so, how? And if not currently possible, how soon can we expect this?
That's a good and recurring question. Okay, other regions can be made on demand. Okay, for that we need to know where there is an interest to do that. Okay, now we have heard about India, Southeast Asia, and maybe others. Okay, that will require some time from one of our technicians, a computer science person, okay, in order to adapt some of the algorithms and the infrastructure that is behind. And apart from that, when he starts, I think that relatively soon, but I cannot commit now to a date, okay, the data should be available on the website. But again, we do that on demand, or once a need has been detected. It was the case of Spain, and then in the frame of this other project, Ghana and South Africa. Other regions, please let us know, and we will be happy, okay, to collaborate with you to provide this data as soon as we can.
Thank you. And we have another question from Ebidin, who is asking: is there a plan on how to involve other African countries to key to the project to expedite and improve data collection across all regions?
I mean, right now, the project that we had that was sponsored by IEEE GRSS, okay, finished June last year, I think, yes. More or less June last year, okay? And we will need to make another application for a continuation or an extension of that project, which is something that could be done within the next couple of months. But right now, I mean, we need to make this application.
Thank you, Adriano and Mercedes. And it is really good to see so many questions and interest in this in this whole project. And I think that is the main reason for these webinars. It's not just sharing these amazing examples, but also getting people who have interest in this area to come forward with their ideas so we can build areas of synergy. So I really hope, Adriano and Mercedes, you got some ideas for follow-up with many of the people. And I request everyone who is interested to, again, please contact directly both the speakers so that we have discussions following up from today as well. So I want to, because of the time is now nearly finished for this webinar, I want to first thank our both excellent speakers for sharing this amazing project with us, which is very interesting for the whole GODAN community, for the wider GODAN community as well. So we have recorded this webinar, and we will make this available for everyone who are not able to attend as well. So there will be much bigger, wider number of people who will be able to learn and listen from this webinar aspects as well. So on behalf of the Global Open Data for Agriculture and Nutrition, I want to thank again our speakers and also everyone who was able to attend today's webinar. And more importantly, I want to thank the colleagues in CTA, Chris Addison and Chipo Messingini, who have helped us launch this webinar using their platform. So thanks to them as well. So all this, if you have any follow-up questions, feel free to put that questions in the GODAN webinar capacity development webinar mailing list as well. So then we can follow up these discussions by email as well. So it will keep on going. Discussions will keep on going. So for the so you can make sure these ideas are taken up for future as well. So thanks again, Adriano and Mercedes, and thank you all for joining today's webinar. Bye for now.
Thank you, Sushit, for inviting us, and thank you for making it happen.
Thank you very much.